Now that you have read the review article on using the discriminant on the reverse side of this paper, I want you to complete this extra practice. At the beginning, the first 3 problems say to solve using the quadratic formula, and then use a graphing calculator to check your solutions. So you should do that now. Once you have completed the first 3 problems, we're looking at problems 4 through 6 to find the discriminant of the quadratic equation and then describe the number and types of solutions of the equation. So you're going to do just the discriminant portion of this. You're not using the whole quadratic formula, just the discriminant. So now we will use the formula for the discriminant and calculate the discriminant to see how many solutions there are for these problems. So we're calculating b squared minus 4ac. (34 squared minus 4 times 1 times 289. What we're interested in here is just whether or not the discriminant is positive, negative, or 0. So calculating 34 squared, we get 1156. Negative 4 times 289 is minus. It's also 1156. So the discriminant is equal to 0. From your notes and reading the article on the reverse side of this paper, you know that when the discriminant is equal to 0, there is one repeated root, or 0. So what this means is that whatever your parabola looks like, it's going to have the vertex on the x-axis. So you will have one repeated root for this equation. For the next one, for problem 5, the first thing you have to do is put it in standard form. So we're going to subtract the 3 and add the 8x to the other side. Does not look like an 8. So we get x squared plus 8x minus 3 equals 0. And then for our discriminant, we get b squared, which is 64, minus 4 times 1 times negative 3. So the issue here is that we have a negative times a negative, which makes that positive. So 64 plus whatever that is, in this case 12, is going to be a positive number. So what we're concerned about is that it's greater than 0. When it is greater than 0, this means that there are 2 real roots. Then for the last problem, again, standard form, we need to subtract the 3q. That gives us 4q squared minus 3q plus 1. So our discriminant is negative 3 squared, which is 9, minus 4 times a, which is 4, times 1, which is c. So in this case, we get 9 minus 16, which is negative. Negative tells us that there are no real solutions. Or roots. However, there will be 2 complex roots. So this is the plus or minus I kind of solution. Moving on to the last portion of this paper, I want you to work this problem, problem 7. But you'll need the formulas from page 278 in the textbook. So if you'll just look at page 278 in a textbook, then at the top of that page, it gives you the formula to use for when an object is falling, and the formula to use for when an object is being thrown or hit in some way going up into the air, which is what is happening here because the baseball player is hitting a foul ball. So you'll need to get that formula and then plug in the values. It gives you the value for velocity. So this is the value that goes in front of x. In the formula, it'll tell you velocity. And then the constant at the end, which is the height from which it starts. And you'll use that formula for a to write the function. And then you'll use the function that you just wrote to calculate the values for b and c. That concludes the notes for today's lesson. Follow the rest of the directions in OneNote for the rest of class.